A year ago, we thought we found what we believe to be signs of microbial life on the Mars surface. And so we put it out to our scientific friends to pressure test it, to analyze it, and go, did we get this right? Do we think this is signs of ancient life on Mars? And after a year of review, they've come back and they said, listen, we can't find another explanation. So this very well could be the clearest sign of life that we've ever found on Mars.
You've probably seen the headlines pop up in your feed. Things like, NASA finds possible signs of life on Mars. It's the kind of world-changing discovery we've all been waiting for, if it's true. For decades, we've stared at the red planet asking one of the most profound questions there is. Are we alone? Now, NASA's most advanced rover, Perseverance, or Percy to its friends, has drilled into an ancient river delta and found something, well, something truly intriguing. This potential sign of life is being called one of the most compelling clues we've ever had. But we've been burned by false alarms before. This isn't a fossilized alien or a Martian skeleton. It's something far more subtle and, in a way, much more complex. So, have we really done it this time? Have we finally found evidence of our Martian neighbors? Or is the red planet playing tricks on us once again? Join me today as we dig into what Perseverance actually found, why scientists are so cautiously excited, and what it will take to prove we're not alone in the universe. Let's break it down. To understand this discovery, first, we have to go to the scene. A 45-kilometer-wide crater on Mars named Jezero. Billions of years ago, this wasn't the cold, empty landscape we see today. It was a place of water. A powerful river carved a valley through the crater rim, flowing into Jezero and forming a vast lake. Where water flows, it carries sediment, creating a fan-shaped delta, much like the Mississippi River Delta on Earth. And on our planet, river deltas are teeming with life, and the fine-grained mud and clay they deposit are exceptionally good at preserving the delicate traces of that life. You see, this is precisely why NASA sent Percy here. Its mission isn't just to explore, it's to be a robotic geologist and astrobiologist, kitted out with a drill and a suite of advanced instruments. Its primary goal is to hunt for signs of ancient microbial life, what scientists call biosignatures, and to collect the most promising rock samples for an eventual return to Earth. For years, Percy has been methodically exploring the floor of Jezero crater, but recently, it reached a particularly exciting spot, the edge of that ancient river delta. Here, the rover has been analyzing rocks that look different, rocks that hint at a complex, waterlogged history. It was in this area that Perseverance drilled and collected some of its most fascinating core samples to date, tiny cylinders of Martian history that have the science team buzzing. So, what did Perseverance actually find inside these rocks? When the rover's instruments analyzed the cores, they saw a tantalizing picture. Using its advanced chemical scanners, instruments with names like Pixel, the planetary instrument for X-ray lithochemistry, and Sherlock, the scanning habitable environments with Raman and luminescence for organics and chemicals, the rover peered into the rock's fundamental composition. The analysis revealed an exciting mix of ingredients. First, the rocks were found to contain organic compounds. Now, the word organic can be a bit misleading. In chemistry, it just means molecules containing carbon. While these are the building blocks of all life as we know it, they can also be created by purely geological processes. So, finding them is a great sign, but it's not proof of life on its own. We've found organics on Mars before, but here, it was what the organic molecules were found with that made scientists sit up and take notice. They were found intimately associated with minerals like sulfates and phosphates. This wasn't just a random jumble of chemicals, it was a structured collection of materials, organic carbon, sulfates, and phosphates, all concentrated together within a rock that, based on its texture and geochemistry, we strongly suspect was once soaked in water. On paper, this is exactly the kind of chemical fingerprint that ancient microbes could have left behind. This brings us to the core concept of the whole search, the biosignature. A biosignature isn't the alien itself, it's the shadow it leaves behind. Think of it like a fossilized fingerprint. On Earth, we know that microbes are tiny chemical engineers. They consume minerals and excrete others, fundamentally changing the chemistry of the rocks they inhabit. They can take iron and sulfur from their environment to create energy, leaving behind very specific mineral clues in the process. The combination of organics and certain sulfate or phosphate minerals found in Jezero is compelling because, on Earth, these associations are often linked to microbial activity. For instance, some microbes thrive in low-oxygen, watery environments by using iron and sulfates to fuel their metabolisms, a process known as chemosynthesis. So, the hypothesis is a thrilling one. Perhaps, billions of years ago in the waters of Lake Jezero, tiny Martian microbes were living in the mud. As they lived, they changed the chemistry around them, creating distinctive concentrations of minerals and organic matter. The rock then preserved this chemical evidence, this potential biosignature, for billions of years until a six-wheeled robot from another planet came and drilled into it. But, and this is probably the most important but in all of planetary science, before you can claim you found a sign of life, you have to prove it couldn't have been made any other way. Science is ultimately about falsification. It's not about proving a hypothesis true, it's about systematically trying to prove it false. This is the case for geology. Mars is a geologically complex world. For billions of years, its rocks have been exposed to intense radiation, strange water chemistry, and processes we're only just beginning to understand. So let's be skeptics for a moment. Could these findings be a false biosignature? Something that looks like life, but is just the result of exotic, non-biological chemistry? The answer is yes, it's possible. Complex interactions between water and rock can create a wide variety of strange and wonderful structures, concentrating certain elements in one place. Geochemical reactions, with no biological help at all, can form organic molecules and mineral patterns that mimic those made by life. The history of the search for extraterrestrial life is littered with promising signs that later turned out to be clever geological tricks. Scientists are currently modeling if the specific conditions of ancient Mars could have produced the exact combination of organics and minerals Perseverance saw without any microbes involved. It cannot be ruled out. So if it could all just be clever geology, why is this being called a potential game changer? The reason is the convergence of evidence. It's not just one thing. It's the discovery of complex organic molecules located right next to a suite of minerals known to be associated with life on Earth, all found together inside a rock sitting in what we know was a habitable environment, an ancient lake bed. Any one of these things on its own would be interesting. All of them together, in one place, is what makes these samples so tantalizingly different. It presents a coherent story. This find is also bolstered by discoveries from the other side of the planet. NASA's other rover, Curiosity, has confirmed the existence of a diverse collection of organic molecules in its location. These findings prove that ancient Mars was not only capable of creating the complex molecules necessary for life, but more importantly, that its rocks are capable of preserving them for billions of years. Taken together, the work of both rovers is building a powerful case. We haven't found life, but we have confirmed that ancient Mars had all the right ingredients, and that evidence of those ingredients can survive to this day. We've gone from asking, was Mars habitable, to where are the best signs of that habitation preserved? These samples from Jezero may be the first great answer to that question. This brings us back to our title. Have we really found life on Mars? The official scientific answer is no, not yet. The instruments on Percy and Curiosity are marvels of engineering, but they are still field instruments. They can spot intriguing chemistry, but they lack the definitive power to distinguish a complex geological artifact from a true biological signature. To do that, to make what would be the most meaningful discovery in the history of humanity, We need to bring the evidence home. This was the entire point of the Mars Sample Return mission, a hugely ambitious plan between NASA and the European Space Agency to retrieve the samples Perseverance has been collecting. However, the mission has been fraught with financial struggles and uncertainties. With an estimated price tag soaring over $11 billion, the original plan has been deemed unworkable, causing major delays and forcing NASA back to the drawing board to find a cheaper, more feasible design. This is despite the National Academy's Decadal Survey, a meeting of top scientists who set future priorities, naming Mars sample return as their highest priority 2 decades in a row. And that was before we found these latest tantalizing clues. This is a stunning setback, but the story isn't over. NASA is now evaluating new, hopefully more affordable, ways to get this done. The scientific need is simply too strong to ignore. Those samples represent the culmination of decades of exploration and contain what may be the most important scientific data of our time. The search for life on Mars has now entered a new, uncertain, but incredibly exciting phase. The question is no longer just a philosophical one, it's a tangible investigation with real evidence waiting to be analyzed. We haven't found definitive proof of life, but in the mudstones of Jezero crater, we may have just found the most promising place to look for it. Now, the challenge is to find a way to get back there and bring a piece of it home. Following what happens next is to follow the very frontier of human discovery. If you want to stay on top of this incredible, ongoing story, make sure you subscribe.